Now, when I start with AWS, before I start with data engineering, let us try to understand what is mainly Amazon. So Amazon, everybody knows Amazon is a company, multi-billion dollar company, where they go and mainly focus on selling the books on online. Later, they moved to like selling DVDs and other electronic devices. But most of the people does not know that Amazon also started selling the infrastructure services too. So when Amazon they started this their own business on this area, they since they got so many so much like a growth in their business, and they got a success in their business, so they want to use this infrastructure services also one of the area they want to focus, and they want to go and see like how they can go and sell this particular infrastructure as a service, and so that they want to even capture that in industry and business also. So they only started the most of the cloud services and infrastructure services. Why they started is majorly they want to give, they want to democratize the infrastructure needs, first of all. And when they started in 2006, officially they launched Amazon Web Services to the market, and now they became one of the major provider in the cloud computing services. And they started with two services, and now you can imagine they have more than 200 plus services which will fulfill most of your requirements. You can implement machine learning. We have a service called SageMaker. We can implement data services. We have different data, like data engineering services available. We can implement DevOps. We have services, group of services. We also have IoT services and data analysis and data visualization. Many different services available to achieve your goals. And when I talk about like Amazon, so Amazon AWS is a collection of remote computing web services which will together make up a cloud computing platform which is offered over the internet by Amazon.com. So what is mandatory here to access AWS? A decent internet connection is mandatory because it is in the cloud. And the website where you go and access AWS cloud is aws.amazon.com. You are not going to install any software here. You are going to access a web portal which will allow you to access your infrastructure services throughout the web portal called Amazon Management Console. You will go and access that particular portal from anywhere using any device during any time. And AWS is located in 25 plus geographical regions, and each region is wholly contained within a single country. So when I talk about a region will, for example, in India, we have in Mumbai region, and Indonesia, Jakarta. For Singapore, in the Singapore itself. For US, you have more than 4 to 5 regions. And even Australia, you have 3 to 4 regions. So every region will be going to provide access of the data to the customer with the high secure data centers maintained by Amazon. So most of these geographical regions will be accessed whenever you go to that particular region location. And what is the cloud computing? When I talk about cloud computing, a cloud computing is going to provide the user to create and access their resources from anywhere by using any device, anytime. Anywhere, what is meant by anywhere? We can access your services from office or from home, or even from a restaurant, or during the travel, or by using any device. Means any laptop I can access. I can use tablet, desktop, smartphone, any device I can use to access the services, and during any time 24/7. That is called cloud computing services, which is going to provide the infrastructure or resources will be accessed by most of the users using this particular option. Now, what Amazon is offering? Amazon is offering majorly these are the benefits where cloud computing is providing, and Amazon or any cloud computing platform is providing. Pay as you go. Pay as you go means whatever you are going to consume you are going to pay for that only. If you are using only Redshift, you are going to pay for Redshift. If you are going to use S3, you are going to pay for only S3 service. So whatever the service you are going to use, and you are going to pay for only for that service. Other services are not chargeable. And access from anywhere, anytime, any device. This is what I just discussed about. And economy of scale, to scale up and scale down, is very economical. For a simple single service, you can pay in minimum not only like dollars, you can even pay in the cents also. And the flexibility. Flexibility means which will provide you a facility to access your services from any particular device and during any time, and you can immediately go and access after you create the service. And expertly managed. This is also important to understand. Expertly managed means every service in the AWS environment will be managed by a group of experts, subject matter experts in that particular service. Redshift will have a separate dedicated Amazon Redshift team who will take care of Redshift service to manage. And you will have separate S3 service team who will take care of S3 service. So every service will have a dedicated team who will take care of that particular service. So we can call AWS is a expertly managed environment. And apart from that, what AWS is offering? So AWS is offering availability, scalability, and pay as you go. These three are one of the three some of the important factors why companies are moving to AWS. First and foremost thing is like availability. What is meant by availability? Availability means Amazon promises 11 nines availability, 99.999, 11 nines availability, because I will give a scenario. Assume you are willing to travel to from India to some other location, UK, and you want to provide a presentation. And before cloud was there, how people used to carry the files? If I ask you, pen drive, right? Correct? Yes or no?
Yeah.
So what happens if my pen drive will be damaged in the travel? Can I give the presentation or no? Provided I have a backup. I don't have any backup also. Definitely I will be in a risk. Do you agree, all of you?
Yes.
Yeah.
So what if I have a Google Slides, for example? The same presentation I prepared using a Google Slides, and I can access from anywhere using any device during any time, right? Do you agree, all of you? Now you understood the benefit of cloud? Compare it to availability means that data will be available 24/7, and I can access from any location using any device. I can access my Google Slides using my mobile also, correct, right? Or a laptop or a tablet. I just need to log in into my Google account using my Gmail. And I can even change. I can start preparing my presentation using laptop. I can go and later modify it using my tablet also. So that is what the availability. And also scalability. Scalability means a ability to grow the size. Assume I want to increase my size, hard disk size. And in general, if you go to any database servers, in Oracle or SQL server, I first need to stop the database server and then I need to increase the size. And also I need to buy so much of infrastructure which I don't even know whether how much I require. And instant elasticity, which is like scaling up and scale down. This is what AWS is offering. And before AWS was there, people used it to plan their infrastructure capacity in advance. Even I used to be part of my infrastructure meetings where I used to buy so much of infrastructure in my project, and I used to plan so much of budget so that I can use that for my big data projects. But later we go and see most of the infrastructure used to be wasted also sometimes. And that to eliminate such kind of avoid the infrastructure needs in advance, cloud came into picture. I can go and buy instant servers whenever I require. That is the benefit of scalability. And then pay as you go. Pay as you go means low ongoing cost and the pricing will be with no upfront expenses or long-term commitments if you go with the AWS cloud. We do not need to buy anything in advance or anything to pay in advance. You can use it and you can pay. You can utilize Redshift service and you can pay for what you use it for Redshift. And you can use Athena. You can pay whatever you use it for Athena. There is no any restriction here. So pay as you go also is one of the just like a credit card bill. And one more thing which we need to understand here is AWS is the topmost cloud service provider in the market compared to Azure and GCP now, because AWS started first and they already captured, they are the leaders in the market. And we have Alibaba Cloud, also Oracle Cloud and IBM Cloud, but they are very far in the market, very, very far behind. So we need to focus more on these three, but we are focusing more on AWS because that is top in the market. Now, let us understand about some fundamentals of data warehouse also. Since we are going to work on a data engineering, we need to understand what is a data warehouse first. And then we also need to understand what is a big data warehouse, and then followed by need to understand what is a big data lake too. As a data engineer or big data engineer or cloud data engineer, you need to deal with every time a data warehouse. So when you go and see in early 2000s, before cloud was not there or before any like data warehouse were not there, people used to store the data in the 90s in the form of databases. And they used to manage the databases and they used to store the data and extract the data whenever needed. Oracle is one of the famous database. SQL Server, Sybase, MySQL, Postgres. All these RDBMS databases were people using to store their enterprise level data. When 2000 decade came into picture, slowly companies started thinking like how to analyze the data, and normal traditional databases are not sufficient for that because the data will be most frequently changing. The birth of big data happened. Sorry, birth of data warehouse happened. I mean, sorry. So in 2000, you can imagine how the company slowly migrated to data warehouse because majority companies started analyzing their data in their environment and they want to start building reports. So they started building their own enterprise level data warehouses. What is a data warehouse? A data warehouse is a database itself which will have the historical data, past data, which is fall under online analytical processing. To maintain or manage this big data warehouses, we need to know that data will be stored in the form of databases like Oracle and SQL Server and the CSV files. But after the data is stored in the data warehouse, you need to go and use tools like crystal reports, business objects, MicroStrategy, SSRS. These kind of Tableau was not there at the time. Only these tools were there to generate the reports. And how to perform ETL pipelines, Informatica was very famous at that time. So most of these tools, companies were very extensively used to build their enterprise level data warehouses plus generating reports. And what were the sources of this data? Internal products and CRM applications. And how the data was people used to store in structured format like relational databases. Even my data warehouse is a database only, but with historical data. And required knowledge to work on these data warehouses also is SQL and PLSQL if you are working on a Oracle data warehouse, and TSQL if you are working on a SQL Server data warehouse. And data loading frequency also was batch that time. Batch means you will store the data which is already available in one location and try to refresh your database from the real-time data on a weekly basis or daily basis. Depends upon your business hours. So that is how conventional data warehouse have been built. And after 2010, what happened? Data has been grown very, very high. What is the reason for data growth in 2010? If I ask you, anyone? Anybody can answer this. What is the reason for high data growth after 2010? If I ask you. Anybody can answer. It should not be a right answer. Okay. Who will answer? What will be the reason for high data growth after 2010? What happened after 2010? We got social media, correct, right? Yes or no? Do you agree?
Yeah.
The social media, Facebook, Twitter, LinkedIn, Instagram, all came into picture, right? Most of the unstructured data has been generated after this. Before 2010, there was no unstructured data at all. Even it is there, it was there, it is very limited. Videos, images, documents all got generated very in high growth, in high capacity after Facebook came into picture only, right? Facebook, Twitter, Instagram, WhatsApp, and YouTube. And all this became one of the biggest sources of high data growth. And even to maintain this particular high, huge data, and we got varieties of data also. Till before 2010, we were only having structured data. After 2010, we got semi-structured and unstructured and quasi-structured data also. Semi-structured data. What is semi-structured data? Who knows here? Anyone knows what is semi-structured data by any chance? Who heard about JSON files or XML files? Did anybody heard about JSON and files and XML files by any chance? JSON and XML are also similar to CSV, but they are partially structured. CSV and Excel are in the form of rows and columns. But JSON, Parquet, Avro, and ORC, these are all partially structured data, which we cannot even review them easily. So most of the big data projects got started using this particular semi-structured data, and some of the applications also started using unstructured data also. To manage this kind of data, we got big data into picture. Big data means Hadoop. Hadoop means HDFS and MapReduce. HDFS for storing the data. Any amount of huge amount of data can be stored on HDFS. To process this huge amount of data, companies started using MapReduce is the framework. So MapReduce after some time became obsolete because it cannot process live streaming data, plus it also having challenges to process the data and it's very slow. So Spark came into picture and it replaced MapReduce. And after data has been centralized in big data environment or big data warehouse, companies started leveraging tools like MicroStrategy and Power BI to process this data and generate reports. And slowly big data warehouse became big data lake because majority of the real-time data also people started capturing live streaming data. So a data warehouse and data lake. Who knows the difference between data warehouse and data lake? Any idea? Anyone? By any chance? A data warehouse will store historical data, and a data lake will store what kind of data? It stores both historical plus live streaming. So live streaming means your ATM transaction, whenever you are credit card transaction, whenever you go and swipe your credit card, that immediately someone has to capture it and display in a report. Then that is called data, like live streaming data. So to capture live streaming data, we normal traditional databases or any particular tools are not sufficient. So Kafka came into picture, a framework in big data, which will capture real-time data. Later, after Kafka, we got Flink, Storm, and in cloud side, in AWS, we have a framework called Kinesis, which will be used to achieve the same. So most of the data to manage in big data, we need to learn Java. So Java is one of the like framework which are language people used to learn. And after MapReduce became obsolete, and slowly Spark captured the market, and Spark became one of the master in big data side with PySpark. And live streaming data and batch data, both people started capturing, and social media also became one of the source, and people who were able to capture live streaming and real-time data, they started building applications which are related to recommendation engines and fraudulent transaction detection systems. I'll give one scenario. Like for example, assume you have a credit card and you lost it. And once you found that you lost it, you go and call the call center and you will inform them that you lost it. And suddenly, after you informed the call center, you got a notification to your mobile that there was a transaction happened on your credit card. and someone you are using it. Will you be happy? Will you accept it first of all? If your credit card used by someone, even after you informed the bank that you lost the card and asked them to block the transaction, and the bank did not block it, what is your response? You will not accept, right? Yes or no? You will fight with the bank and you will say why you have not blocking my transactions, and even on top of it, bank came to you after 1 week and sent a notification that there was a suspicious transaction 1 week back in your account or your credit card. Definitely you will go and fight with them. Why you have not blocked my credit card transactions? So bank has to do that. Bank responsibility is to, once the customer came to us and notified that he lost the card, the bank immediately need to block the every transaction which is going to happen on that card, or block the card. The credit card fraud transaction detection system should be there to immediately capture the real-time credit card transactions. We definitely need to have a real-time data like ingestion framework and real-time data processing framework that can be implemented using the Kafka in on-premise, Kinesis in AWS. We are going to learn about Kinesis. And recommendation engine. How many people experienced or got recommendations in Amazon when you buy any product? When you buy any product, once you before moving to the cart and pay the money, you might have received some recommendations, right? Did anybody receive that by any chance? Anytime? And they will send you some recommendations, right? To buy few more products with the product you are going to buy. How many times, how many people experienced that? I ask you. Every time you experience or not, my question. Are you guys using Amazon or not? My question. When I'm using Amazon, how many times you experienced that you were like you received some recommendations? Anybody can answer. Not Suhas. Did any time you experience some recommendations or not when you buy any product in Amazon?
Yeah, I get always.
So those recommendations, why did you anytime you got a question, why I'm getting the recommendations? Why I am only getting, correct, right? Why I'm not getting like other recommendations? Because the recommendations also related to what you are interested, correct, right? Most of the times.
Yeah.
So the reason behind that is you will have a separate recommendation engine assigned to your user. Amazon will do that. For every user, there will be a recommendation engine will be running to provide some recommendations whenever you go and buy something. To build such kind of recommendations on fly, they have to analyze your data. So to do that, we need to have a live streaming data ingestion system that can be only implemented by leveraging the big data lakes only. Okay. So apart from that, you also need to understand when you are maintaining this particular big data lake or want to convert a data warehouse engineer to big data engineer, you will experience so many challenges. Every data warehousing engineer, if at all they want to become a big data engineer, in 2010 decade, they need to know so many frameworks like this. Even I got to learn all these frameworks except one or two I didn't learn. The SOLR I don't know. I know rest all the frameworks here. I worked on every framework to build a big data lake for MasterCard. So what is meant by my conclusion here? Every person may not be interested to learn these frameworks to become a big data engineer, because this many services means there is very big learning curve will be there. This is the challenge for every developer to convert into a big data, and even companies also will have some challenges to like maintain this big data environments, because they need to maintain the big data environment, which is very hard. They need to perform patching and upgrading, and manually they have to like intervene, and they have to go and do some memory optimization, all in the big data environment. And one more like the important thing is finding the technical resource who knows all these frameworks also very, very difficult. And who knows managing the Hadoop cluster also is not easy to find out. And we cannot reuse the existing people who are already working in data warehouse because not everyone is interested. Rare resource means high salary also. So which means that all these will become challenges for the companies to maintain their big data environment. So we need to understand what is the reason behind that is the data volume growth. That is one of the challenge for every company experiences that. And by 2020, 200 billion devices are there, and 90% of the data got generated within a span of 2 years. And daily 2.5 like 20 million of bytes of data is getting generated. And how to maintain that? Not easy, correct, right? So to achieve that, we need to go and have the big data lakes. Okay, when I talk about any data engineering, you also need to understand structured data, unstructured data, and semi-structured and quasi-structured data too. So you, as a data engineer, you may not need to work on unstructured or quasi-structured. You definitely need to work on structured and semi-structured, because majority of the times you will work on this kind of data to create the ETL pipelines. So you cannot go and skip semi-structured because that is important. So most of the big data projects are using JSON, XML, Parquet, Avro, and ORC, this kind of data also. And what is a data lake? Now, a data lake is a centralized repository which will allow you to store all your structured, semi-structured, quasi-structured, and unstructured data at any scale. So as a data engineer, I should be able to create a data lake with all the below features. A data lake which I'm going to build will be one place where a single source of truth. It should support different types of file formats which we discussed just now, not only CSV. It should support JSON, XML, Parquet, Avro, ORC. All these file formats also should be supported. And it should also support fast data ingestion and consumption too. Since my data volume is high, I cannot go and say the ingestion will be slow. And the schema on read, whenever you're going to store the data, you should be able to read the data. And data lake is designed for low cost storage. You should be able to compress your data. So Parquet is one of the data format to compress your data. And a data lake will decouple storage and compute also. It will separate. And when you are building a data lake, you should separate them. There should not be any dependency. If there is a dependency, you will experience some downtime. And it should support data protection and security also. Most of the banks will be particular about data protection security because they want to protect the customer sensitive data. They use different data masking methods too, where my phone number will be masked with hashes, or email will be masked with asterisks, like that. So data should be protected. So we should have the feature. Even AWS have some services to implement this data protection too. And once you understood about this particular data varieties and what are the different characteristics of data lake, you also need to understand how to refresh this data lake using a data pipeline. So every data pipeline will have all this terminology: data sources, data ingestion, data storage, and data transformation, and data catalog, and how data pre-processing and analysis, and finally data consumption. Every box here will have some set of services or tools which are going to involve. So data sources, you'll see most of the data sources like will be structured, semi-structured, as I mentioned, quasi-structured, and unstructured. And once my data is ready and I decide these are the sources, I should be able to ingest the data. To ingest the data, I need to depend upon some of the data ingestion tools or services, like data migration service is one example, where I want to migrate Oracle database in my server, on-premise physical server, to a RDS database server. or AWS Kinesis to process the real-time data. And once my data has been ingested and it will be stored in one of the data storages, that is where S3 will come into picture in AWS environment. And S3 is a service that is going to allow you to store the data in the form of files. So Amazon S3 is going to help you to store the data from any of the sources. And once my data is stored, I should have a metadata should be generated with schema. To achieve that and create ready-made metadata to create the tables, we'll use a glue catalog. So glue catalog is going to help you to create the data like metadata, and so that I can use them immediately. And glue is a ETL service to process your data from source to target. And once after my data is like ETL pipeline is ready, and we'll store the data in any one of these particular targets, then we'll try to analyze. So my data can be processed and analyzed by using any of these particular services. Athena, a serverless query engine. I write some SQL queries on top of the data. Amazon EMR, I'll try to use this for big data processing. And Redshift to store the data in the data form of data warehouse and process it. And Amazon Elasticsearch is basically used for unstructured text data. All these services will be used to process and analyze the data. And finally, whatever the data you centralized and processed and analyzed, we use the consumption layer where you won't use any one of these particular services. For example, I will use a QuickSight dashboard to connect to Redshift or Athena. I can generate some dashboard. And Amazon API gateway to connect and generate some kind of data for API. And Jupyter notebooks to connect to this particular like services, one of the services, and build an ML model, or connect to any one of the services and try to use a Looker dashboard too. So all these are some of the services which as a data engineer we should know. Apart from this, we also need to understand about Lambda, one of the service, and also need to know about DynamoDB and RDS, and also need to understand about majority of these particular services are part of data services, and which we are going to learn about the services one by one as part of our training. And this is about data engineering stack, which usually I want to go and discuss more about. And coming to like data engineering stack, we also need to understand some of the services which I mentioned here. So if you see here, Amazon S3, and we have like Amazon S3 for storing the data, Glue for ETL, and Redshift for storing the data in the form of rows and columns, and Kinesis for streaming data capturing, and IAM for managing your AWS environment with the users and groups, and also Lambda for running your code without any server. All these will be majorly utilized to maintain your AWS environment data pipelines. And we go and see a majority of the services will have, every service will have its own responsibility. And if you see here, every data engineering process will have like data collection, and I will use any one of the services for the data collection, and the data preparation I do by using all these particular services S3, and also like key spaces for managing the security and encryption. And also we have DynamoDB and Redshift for loading the data in the form of structured and like NoSQL kind of data. And data quality checks also can be performed by using Glue or EMR or any of these Glue data quality checks also. Why we need to perform data quality checks is because I need to see whether my data from source to target successfully loaded or not. To maintain the data quality, we'll perform data quality checks. And after your data is centralized, we'll use Amazon QuickSight for the data visualization. And anything that you want to monitor, any service, we have Azure CloudWatch, Amazon CloudWatch. And all these will be services which we are going to majorly focus on data engineering side. And you can see here, majority of the services we are going to cover here. All data engineering services, whatever you see, we are going to cover all this. S3 for data storage, AC2 to go and create like a virtual instance or virtual server, EMR to build a big data lake, EMR will be used to store your data in the form of like data warehouse, I use Redshift. And Glue for serverless ETL process to perform ETL activities, I use Glue. And Athena for interactive queries to be executed on top of the data which is available in the form of files in S3 bucket. I'll use Athena. And Kinesis to process real-time data where I need to go and process real-time streaming data, I use Kinesis. So all these services we are going to learn one by one. Along with that, we also learn about DynamoDB and also Lambda majorly. And every data engineering life cycle will be data creation, data ingestion, and data storage, and data transformation, and storing in a data lake, and finally consumption, which we already discussed about in the pipeline. This is how every data engineer will day-to-day life will be. They start with data ingestion and store the data in a particular location like S3 and perform some transformations on the data which is in S3 and then try to push into a data warehouse or data lake. Once my data is available in this data lake or data warehouse, I'll connect through data visualization like QuickSight and consume our data. So that is how you need to build a data pipeline. And we have different services available for data ingestion and storage. So data ingestion into AWS can be done. Kinesis is one of the real-time streaming engine I told you. And for data storage, we use S3 or RDS, Redshift, DynamoDB. All these can be used for any of your project. And once your data is ingested and stored, I need to perform some transformations on that. So I will use AWS Glue for ETL. And any big data I want to process, I use EMR with Spark. And any real-time data I want to process, we use Kinesis data streams. And once your data is processed and transformed, we'll push into a data warehouse where Redshift is one of the solution to store the data. And then we will follow some of the data integration with Redshift, with Glue and S3 and Athena. And once my data is stored in data warehouse, then I will use a orchestration also to maintain my big data pipelines. And I will use step functions is one of the solution for managing your pipelines in the AWS environment and orchestrate them. And to monitor any of the services, I will use AWS CloudWatch and manage that using Lambda. And any data governance, I want to go security, you want to maintain, you have data governance policy, and we have AWS encryption and IAM policies. We can go and maintain that. And finally, performance optimization and cost management also important while using the services. You need to frequently monitor your billing using Amazon AWS billing service. And because every service, if you use, you have to pay for that. So you should be very careful. And that's about which I want to discuss more about like AWS big data services and the data pipeline. And as part of this training, we are going to cover most of the framework which I talked about. Like, so as a data engineer, I should know SQL and I should be very strong in SQL. If I don't know SQL, it is not easy to manage any data engineering projects. So I'm going to cover SQL foundation. I go with MySQL. I'll go and explain and we'll discuss more about MySQL database and all the SQL commands and joins, set operators, and built-in functions, aggregate functions. We'll go and learn about like views and also queries, subqueries, and stored procedures and functions. So I will learn up to advanced SQL. And once you finish that, we'll jump into Python foundation, where we are going to learn Python basics and also advanced Python like pandas and numpy also. And this is going to help you to learn Python, and which is going to help you later to learn PySpark easily. And ETL foundation for understanding, as you are going to work in a data warehousing project, you should know what are the ETL terminology. I'm going to cover all the ETL terminologies as part of this foundation. And once after you finish that, you will jump into like basic AWS services. Like first we start with S3, where we are going to cover the end-to-end usage of S3 service, including like cross-region replication, storage classes, Glacier, and version control. We learn everything through how to do that through management console, plus how to perform that using the command interface also. Once you finish S3, we'll jump into IAM, where we are going to cover about how to manage the users and groups and policies in AWS environment. This is going to control the AWS environment access. And as a data engineer, you should know this service because to understand what roles required in future. And once you finish that, we'll jump into EC2. EC2 is one of the service that is going to help you to build infrastructure in the cloud. So I want to build a Linux server, virtual server, or Windows server. I need to know how to do that. So EC2 is going to help us. Once you finish that, then we'll jump into Lambda, which is going to help you for data ingestion. Lambda with S3, how to upload the data from S3 and how to run a Lambda function to load the data from one S3 bucket to another S3 bucket. We'll see that. Once you finish Lambda function, we'll jump into PySpark, which is one of the important framework to learn. And we are going to learn PySpark with our Python knowledge fast. And we are going to see how to perform data frame operations using PySpark and RDD operations and how to run PySpark jobs. We are going to learn one by one. Once you finish that, we'll jump into AWS Glue to perform serverless ETL jobs to be executed. We are going to learn about AWS Glue and how to set up Spark jobs in Glue, and also like how to go and understand about Glue catalog to create the metadata. We'll learn all this as part of these modules. And once after we finish that, we'll jump into AWS EMR to maintain the big data cluster. If you are dealing with big data, which service I need to use? EMR. The EMR will be automatically managed using PySpark scripting. So whatever the PySpark you learned, we are going to use that here to manage the entire AWS EMR cluster, because we are going to create a EMR PySpark cluster only. And once you finish that, we also will learn about how to run the Spark jobs using EMR. And once you finish this, you'll jump into Kinesis, which is a service to process your real-time streaming data. And we are going to learn about what is Kinesis data streams and Kinesis Firehouse agent. We learn everything as part of this module. Once you finish that, you will jump into like DynamoDB to learn NoSQL database in the AWS environment. And after DynamoDB, we'll jump into Athena, which is a serverless query engine to execute your like Athena, like SQL queries to do some analysis. We are going to learn Amazon Athena as a basic as well as advanced Athena, how to manage that using Python and Boto 3 as well. Once you finish that, then we'll jump into Redshift database and how to manage this entire Redshift database and cluster, and how to manage the tables, as well as how to go and run some of the analysis inquiries, and also copying the data from S3 to Redshift tables, and how to go and manage that. And that too with different file formats, how to load the JSON data, Parquet data, CSV data. We learn all this. Once we finish that, we'll jump into the last two modules, which are like how to manage the Redshift database and the distribution keys and sort keys. And finally, we'll go and learn about Redshift Spectrum to manage a group of Redshift clusters together, and how to perform a high computing engine. Once you finish that, also I'm going to cover as part of this training, which are not part of this curriculum. I'm going to cover Snowflake and QuickSight also, to understand about how Snowflake can be easily integrated with like AWS. Plus, I'm going to cover QuickSight to generate some dashboards. And once you finish all this, I'm going to cover 2 to 3 projects. Two of the examples I gave you, like you're building a analytical platform for e-commerce using AWS services, also building a end-to-end ETL pipeline using AWS EMR and PySpark, and also like we're going to learn about Glue and Glue catalog and S3. And this is about the entire course which I am to cover. And this is the curriculum which are going to cover. This is a 40 to 45 hours course. And a day, like you can check with Dia about the timings, and most of the times we are just planning for weekend batch, and you can check with Dia about the details and all. And anybody have any specific questions? Now this is the time to ask.